Good evening. Welcome joining Get Cloud Smarter on AWS. Welcome joining again. Today we will go through 3 topics all around the AWS. And the topics are interesting to everyone from developers to operational guys who wants to use AWS more and use it to its full potential. So the first presentation will be on AWS CDK, a tool from Amazon Web Services that gives you ability to describe your infrastructure, so more on code as infrastructure, how that looks like. The second one will include development of the actual application. So we will demonstrate Spring Boot, how to build an application, how to start there, and how to put it in AWS so that you can benefit from it. And at the end, there will be cost-saving magic presented that will let you save money while you are on the cloud. And yes, so you might wonder why we are sharing this content. Why are not we just keeping it in TeleSoftas and then that's it? So we want to encourage you to try tools which enable new workflows. And there's lots of talks about the shift left. So you can do that by enabling developers to test their code. And the same way you can enable operational activities to be done by developers. So that's a part of all the presentations. And then the way we will share this is very, very practical. So we share the things that we use in TeleSoftas daily. And these tools powers our developers. And it powers in the ways that were not possible before these tools existed, before clouds was available. During the talks, you can use Slido to ask questions to the attendees. So you can go to Slido, go to TeleSoftas handle, and ask questions there. You see the QR code on the screen, and you can scan it as well, and it will lead to the same place. So we will start off with Pius' presentation and a couple of words about the Pius. I would say that he was born in AWS because he started his career building solutions on it. And then through his career, he learned various things, including agile ways of working, a bit of the architecture. And through his journey, learned that you have to be hands-on to be able to move things forward. And this shift left ideology fits him very well. So please, Pius, come to the stage and let's hear your talk on how I accidentally started doing DevOps.
Yeah, so thank you, Nereus, and as he said, my name is Pius and I'm a tech lead in the TeleSoftas. And today I'm gonna talk about how I accidentally started doing DevOps and how my code no longer runs on thoughts and prayers. Or more seriously, I'm gonna talk about infrastructure as code using Amazon Web Services, Cloud Development Kit, AWS CDK for short, from a perspective from a developer who didn't have that much experience with infrastructure as time went. So I'm gonna start with a small introduction and my motivation behind this topic. Then I'm gonna show you how easy it is to use. And then just gonna finish with some notes. So I'm a full stack web developer, and most of my career I have been, but my full stack included a front end, back end, and various databases. But I could never really get my hands on the typically DevOps portion of work of actually configuring our code. And that's like a hugely important part of what I'm building. And I started noticing that most of my colleagues, or at least many of my colleagues, had a very similar story. So they didn't really have the skills or knowledge to do some basic cloud infrastructure things. So it could be simple things like they didn't know how to like set up and deploy a server to the cloud, or something more practical like maybe you were developing a feature and you could have used AWS service to really cut down on your development time or make it a better feature, but you didn't really know how or have access to use it. And that's not very good for day-to-day work, I think. And I started wondering, why is this the case? Because I think currently developers and DevOps disciplines are very separate. And I'm not completely sure why. I think a lot of it is just it became an extremely different skill set. But I think what's happening right now is we don't have a lot of cross-discipline people who can do both DevOps and just normal or typical application development. And we're losing a bit with it, because I feel like if you think about people who work on front end, back end, kind of like jack of all trades, master of none, they have pretty valuable opinions when you look at maybe at cross-stack stuff, and if there's complexity in your application, they can give you a good view, maybe where should you put that complexity, so overall it's less. But as I said, I don't think we have a lot of that right now. And I think a common scenario when building new projects now is you basically, people at the beginning start up, they develop the whole infrastructure, but as the project and as the complexity grow, you get that infrastructural knowledge very centralized. It becomes a bit too complicated to share. And when new developers join, it's really too hard for them, and it's too time consuming to understand infrastructure well and contribute to it. So that was my story. I started working in a company that was ongoing, and I couldn't really contribute to any of the infrastructure. And my skills and knowledge on the topic really decayed. And whenever we would release to production, I was always a bit anxious, because sometimes it can end up with like, well, it worked on my machine. But it doesn't have to be this way. Infrastructure as code alleviates a lot of that pain and like kind of socializes that knowledge for the whole team. And that's where my story starts here at TeleSoftas. So I joined a project that was using AWS CDK, and it wasn't that difficult. And my full stack got fuller stacker, right? So now I'm gonna show you how easy it is to actually use and do DevOps stuff, well, some, on AWS using AWS CDK. So I'm gonna show you how to just set up a new project, deploy AWS Lambda, and whoever doesn't know, Lambda just runs your code on the cloud. Then we're gonna deploy an S3 bucket, which is like a hard drive on the cloud, and we're gonna make those two interact, and I'm gonna finish up with some notes. So this is the wrong browser. To show you that I'm not lying, we're gonna use 3 of the AWS services, and as you can see, all of them are currently empty. There's nothing there. So to start a new project on AWS CDK, all you need is a new folder. Let's call it friendly. And let's open it in VS Code. we have the window here. And first thing that we're gonna need is to have the AWS CDK locally. Well, for this, I'm gonna be using, I copied the wrong thing. For this, I'm gonna be using TypeScript, just because we're using it day to day. This works in several different languages. Java is one of them. So as you can see, I have it installed locally, and then we're gonna initialize a new repository. So this basically builds an empty node-looking project. It does something very similar in all of the different languages. So it basically builds all of the basic files you need. Currently, it's not doing anything on the cloud. It just does it locally. And the only thing we're going to do is we need to tell it where to look. So it would use our account and not some random account. Cool. And that's it. And now we're going to deploy it to the cloud. And I'm going to show you what's happening in here. So Cloudformation in AWS it's like a template of how to deploy your services. So it will describe your databases, your whatever EC2s, and tell the AWS how to deploy them. And this AWS CDK usually compiles into it, and the Cloudformation actually does the deployment. It is not 100% the case, but it usually is. And this is always a risk. Basically, if you're using several AWS profiles locally, this might crash and burn and give you red errors. Hopefully it will work this time. No, I do not want to update. Cool. So while it's doing its thing, you can see it actually successfully is doing a thing. I'm gonna tell you a bit how the whole CDK looks. So CDK has what it's calling a stack. A stack is like your application's house. It can have logic, but it will only be run during the deployment. And inside the stack, you will be referring to what it's called constructs that I will show in a second. And those constructs actually are parts of your applications. They're certain features. And those can interact between them. Cool. So this is deploying some basic things. Really, I've never read into this. You don't really need to. It just makes it run. And that's why I kind of like this, because it is very easy to start. So we can look at the cloud, and we can see it created some files in the CDK. We don't actually need them, and it just, in your AWS account, it created a CDK toolkit, which basically makes it run better. Cool. So the first thing I want to do is actually deploy a Lambda that runs something. So we're going to deploy a Lambda that we're going to call a greeter Lambda. And this declares basically, okay, this is the thing we want to deploy. And for it to be deployable, we need to create another file that's basically just called the stack's name plus something greeter Lambda. You can directly refer to that file, but I like to structure my code like this because it's a bit cleaner in my in my projects. So cool. We have a Lambda function that's exports a handler. That's an AWS requirement. And basically all it does is return hello world. And I forgot to do a yarn install. And this basically deploys the function. So in a second, I will show you how the deployment actually happens and prove that it works. Cool. Something worked. Let's see if something else works. So all we need to run here is to deploy the CDK. So what the CDK deploy does, nope. It doesn't do anything apparently. Yeah, I probably didn't bootstrap this project. Nope. Let's undo a bit of this, and let's undo a bit more of this. So we're just gonna import the files that we want. Cool. This looks way better, right? So this is a pretty realistic view to my day-to-day. I just basically look at the error messages when I fail to do something. So I have a lot of experience in this part. Nope. So, holy hell, this is a new one. So, yeah. So, fun story. I did this 3 times. Worked out greatly. Yeah, on my exactly the same computer that I'm doing right now. Yeah, it was going great. This time, maybe new features. Yeah, cool. So, I don't know if this happens again. I'm actually gonna look at the error message, and here we are. Cannot read or write on a closed pipe. So I know what happened, probably. So it's trying to deploy into one of the AWS services. So I'm just gonna explain while I'm doing this weird stuff. So when you usually deploy a new Lambda, you need to upload it into S3, and your basically code would pick it up from S3, which is cool. It just takes a bit longer. By a bit, I mean it might take like up to 5 minutes sometimes to do this. And when but you have an option to use this package that they recommend themselves called ESBuild. And as you can see, that was there. So what it did, it bundled the code locally, and it's actually just uploading that straight into AWS. So that makes like Lambda change deployments really fast. Because we're deploying the first time, this can take up to a minute, but normally it could be like 20 seconds, which when you start working on the cloud most of the time, you really lose some of that velocity compared to if you were working locally, because it's way harder to just like throw out some code, see if it works, throw out some code, see if it works, because the throwing out is taking time. But this local bundling, it's kind of very similar to that. Cool. So something is green and something deployed. So let's look in the AWS. So, oh God. So we can see there's a this stack, friendly stack that I just deployed, and this is a Cloudformation stack. So in real life, it looks like this, and this is what you would need to do if you were not using AWS CDK, and this is really cryptic, and I do not understand it, but in reality, this is all I see, create complete, and maybe I can look at events of, okay, what's actually happening right now. And if we look at the lambdas, we can see, yeah, cool, a lambda was created. So in the lambda, you can actually see the code. If it's small enough, once it grows, it's not there. And because in our code, we didn't really care about what event we're sending, so we're just gonna say, yeah, sure, send this event. We just want to confirm that it says hello world. And it does. And cool. So I was able to deploy something to the cloud in an automated way that I can replicate easily in what? 5 minutes. If I didn't do any errors, I would be down to 2 minutes. So cool. But that's pretty easy as it is. You basically upload file to AWS if you wanted to do it manually, right? Or any different way. So for my next trick, I'm gonna create something else, and I'm gonna create a bucket. So where I am, I'm here. Cool. So the bucket comes in one of parts of AWS CDK lib, and it's called S3. And to create the bucket, you really need to, let's say it's a const friendly bucket, and it's AWS CDK. Sorry, I forgot, it's a new bucket. We pass this, we pass a name to it. I'm gonna call it my social anxiety, so you all know how comfortable I feel right now. And that's pretty much it. Okay, so now I'm just gonna run deploy, so it deploys the bucket in the meantime. And so the goal of this exercise is actually to make the lambda right into the bucket, so it actually is not utterly useless. And for that, normally outside of AWS CDK, you would need to probably pass the variables through some other system. So you would need to store a parameter of like, what's the bucket name? Or if you're realistic, you're just gonna copy the bucket's name and pass it to your other code, and not always do it in an automated way. But for this, what we actually need to do is just say we're passing something into an environment variable of the other thing. So we're just gonna say it's a bucket name, and from friendly bucket there is a thing that's called bucket name. And that's pretty much it. So now if I want to react to the bucket from my code, I have this copied so I don't write for a long time, but I'm gonna go through this, what everything actually does while it's deploying. So we say we want something, we want to store hello world string. We initialize a new S3 client, and we're basically just uploading it to our bucket, right? And the bucket name is passed through this process environment variables, which is really weird to do, but it makes it a bit easier. So as you can see, you make the bucket and you pass a reference to the bucket. And most of you might not understand how cool this is, because the other ways are really gross and usually just copy-paste code. But this way, I can kind of forget about it, which I like not knowing things. Cool. So we can see the friendly stack is doing something. And it's updating the Lambda. So it parallelizes those processes. And actually, what you can see here is pretty much the same as you can see in here. I think it just stopped. Yeah. So if we look at our buckets, we can see there should be a new bucket that's called my social anxiety. It's going great. I love these errors. Really, really working out. Now, this is even not my fault. Cool. Okay, so we have an empty bucket. Ta-da! And we have a Lambda that if we refresh, we should see that there's code here, right? It has our new code. So let's do the same. As I showed, we have a bucket, we passed the reference into the Lambda, and we want the Lambda to write into the bucket. And oh, what is this? Oh no, access denied. My Achilles heel of actually configuring the accesses in infrastructure code. I'll need to get some help, or will I? Because I can do some of the infrastructure now. And the error message is pretty self-explanatory, right? It says access denied. So we know that we need for the S3 to give consent to the Lambda to write in it. And even without a true story, I didn't start this error the first time when I saw. I didn't start by Googling it. I just kind of tried writing something, and it kind of worked, because I knew I have a bucket, and I need to either put or write. So yeah, I just need to grant write, and I need to pass the reference to the Lambda. And that's it. It's super easy. I really didn't need to know that much. And I'm going to deploy it now, and I'm going to show you what I would have needed to know otherwise, which is fine. You will end up needing to know a bit more if you use it and how the actual policies look, but I think for most stuff, it gets you going way faster. And just another minute of something happening. And in the meantime, let's see what is it trying to do. Something. Cool. So I think if we look for this, yeah. So this is actually what I would have needed to do otherwise. So creating a new policy that does blah 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 blah. And good luck remembering this, because you're gonna Google it every time you need it. And in day to day, it's not fun to do, because I would usually ask someone else to do this, and they didn't know what to do, and it's a whole thing. And now it's not a whole thing. And we have successfully deployed it. So now, when I say test, yeah, cool, it passed. And if I look at my bucket, this is my file name. Yeah, and I have a file, and if I open that file, it says hello world. So here we go. My social anxiety has something to keep it occupied. And that is pretty much the gist of it. I could literally do like a couple more hours of this, but all this is you declare several services and you make them connect. And I think for me, the biggest problem working with cloud always was there's a lot to know, and it's kind of hard to find that information, and how do the policies interact, and it's a hard topic. And just this, instead of 200-300 lines of something somewhere, it's not even centralized, is way better. Well, it's way easier for me, and I can explore with it, and it's cool. So, cool. I'm gonna go to my finishing notes. Yes, finishing notes. And first I'll go to my pros. So maybe a bit before that, I've worked with this for almost a year now, day to day. It's been out for 3 years, so I'm there for 30% of the time, so it's pretty cool. And I think one of the coolest things about it, well, the two coolest things about it is it's really easy to onboard new people, because they can basically go through your code and look at how everything is deployed. And you kind of minimize the risk of something being deployed and no one knowing about it. Another pro that I wrote down when I wrote this is most services are supported. It wasn't the case like a year ago. It's still not the case that everything is supported right now. For some things, you literally need to paste those like policies, which are long tests. Another cool thing is if you're working already on an AWS project, you can kind of easily move over to this, because if you have a bucket or something, all you would need to do is say, instead of that, you would say AWS S3 bucket from bucket name. And this is basically, if I do not create the bucket in the stack, these two are essentially equivalent. And that is really useful, because maybe you have some more serious stuff from like a bigger database or something, and you don't really want to mess with that with AWS CDK, because it is a bit risky, especially at first when you don't really understand everything that's happening. So you might export some of those like static serious services from the other side. And now going to the cons. So what you saw, it was like 1 minute max deployment times, and I was talking kind of over it, but as your project grows like a lot, those deployment times goes to 5 minutes, maybe 10 minutes, which is a bit annoying if you're actually just developing on it, because we do develop on it. We all have our own AWS environments, and we do everything there. And so if you change a Lambda, it's under a minute. If you change something else that's referenced somewhere else, it will take you 10-20 minutes, and you have to find other stuff to do, basically. Then debugging becomes difficult on big projects, which I guess it's a completely AWS thing. But I feel, because it's so easy to get into this, looking for those error messages or where to look for stuff, it becomes way harder, because you're not that familiar with AWS infrastructure and the whole thing. I really don't like AWS documentation, although I wrote it really politically that it's fine. I feel for the stuff I need, it's never there. And I think it's fair, because it's such a huge service, and they just didn't write the stuff I needed. And no local testing. So there are ways to mitigate this. A local stack, which is like a fake AWS on your machine, which is not made by AWS. And I wouldn't have too much trust in it. Maybe I should, but when I tried it, it didn't work. But most things don't. And but the no local testing thing is actually pretty big negative, because I feel like that instant feedback loop of like, I can try something within a minute is really important when making new things. But with this, you really lose that, and I wish that it wasn't the case, but it is. And yeah, so cool. And that's it. Questions? Hey.
Thank you, Pius. Was a great demonstration with, of course, live demo gods visiting us, right? But despite that, very good, insightful, and actually demonstrating day-to-day life of Pius hacking on the project. Yeah, so audience have a couple of questions. So the first one, a simple one, and the one that might cause a confusion. What are the differences or similarities between AWS CDK and AWS SDK?
So SDK is a source development kit. That's actually, so if you have a bucket and you want the, like we used just now, we changed it, whatever. So with SDK, we would do the action of actually putting code into the bucket. The CDK is Cloud Development Kit. It just infrastructure as code. It just makes everything connect. It's not actually like, doesn't do business logic in itself.
Yeah, I would only add that SDK you use in applications to consume AWS services, where in CDK you define those services that you can use, right? Okay, the next one would be, do you put this code to Git? How often you get merge conflicts?
So yeah, we do put it to Git. We actually started doing it something bit. We started putting all of the lambdas next to our infrastructure code, which would be unusual in most scenarios. It doesn't feel like we get too many merge conflicts. Seriously, in the last 6 months, I got like one. Yeah.
Nice, nice. Then that means you have a nice architecture and nice layout of the files.
Sure.
Not putting everything into one. Cool. The next one question, what are the options for fallback in case AWS is down for some reason? It seems like the product you're building with this infra is completely reliant on AWS.
Yes. And if AWS is down, like half of the internet is down, so whatever. But I think a better argument for not being infrastructure dependent is price. But I think using this, you save on developer price. So hopefully it evens out.
Yeah, and the failures of AWS infrastructure happens quite locally. There are such cases, but there are also tools to avoid that by deploying the application to several locations that AWS provides. And for the development, then remember the university times and code to the paper.
Yeah. Because Twitter is down, you don't even know about it.
The next one and the last one question, then what's the difference between AWS SDK and Amazon Cloudformation?
I think it's what you said is still the same. The Cloudformation is actually doing all of the deployments. The CDK is you describe it here. So yeah, it's the same.
Yes, the same. Just you generate one with each with the CDK. You generate AWS CloudFormation descriptions, and those descriptions was those long JSON or YAML files that you showed in the UI. So people used to write those, and that's not fun. Oh, okay. We have a question in audience.
So GitHub and Bitbucket are mainly repositories, but right now they're basically both have CI, so continuous integration, that once you merge your branches, you can force it to push. So AWS CDK really doesn't care if you use GitHub, GitLab or Bitbucket. I think the main differences will be the continuous integration setups, but they're not that difficult because you essentially, for that part even, you just need to give access for your Bitbucket or GitHub to actually push to the cloud, and that thing just runs CDK deploy. Literally one command. So, yeah.
Does that answer? Thank you.
Unless it fails, then you're fucked.
Any more questions? Okay, then I invite you for a couple minutes of break, take a drink or something else, and see you soon. Welcome back. Further, we continue with our speakers and their prepared topics. So the next speaker is Stephen, our colleague from Nigeria. A couple words about him. He's a leader of Java user group in Lagos. So he's used to organizing similar events and speaking in them. And from the practice, he's the one who asks questions when no one else has those. And he's the one first to share things with others about things. And sharing is not his main trait. He's also a certified developer. And he's working daily with Spring Boot and AWS. And he has prepared us a presentation about Spring RESTfull web services and that application deployment to AWS ECS Fargate. Stephen, the floor is yours.
Hello. Thank you very much, Nereus. Okay, so welcome everybody to the session for Spring RESTfull Web Service and AWS ECS. So Nereus has talked quite a lot about me. So that's just me in the picture with my brand new TeleSoftas smile when I joined in January. So if you to Spring Boot, if you are new to Spring Boot, or if you are a developer looking for easier or a cost-effective way to deploy applications to the cloud, then this session is going to interest you. So what we'll be doing today is I'll actually be building a RESTful web service with Spring Boot. Technically, I won't be building it. I have the code on GitLab, so I'll just pull the code down and do some explanations on it. And in the end, I'll be deploying to Amazon Elastic Container Service, ECS, using the Fargate launch type option. So what I'll be using for this session is I'll be using IntelliJ as my IDE. I'll also be using Git to clone the repository down to my local. Then I'll be using Java 17, but if you have Java 8 on your machine, it's also fine. Then also Docker installed, though not necessary. Then because I'll be pushing to AWS, I need an AWS account. It is free to open. And also I have AWS CLI installed. So if you don't have AWS CLI on your machine, there is a link in the repository on how to download and install it. So this session will be more of demo, and they'll be in two phases. So the first phase is I'm going to demo for you a Spring Boot application that exposes to endpoints. So the first endpoint will just to save employee records to a database, and the second endpoint will be to list all the employee records from the database. Then the second phase will be to deploy the application to ECS. So I'll be building the image, pushing the image to ECR, then also create ECS tags, then finally run the ECS tags. So let's get started. So the first thing I'll do is to jump off to GitLab. I already have the code repository open. This link URL will be shared with you if you want it. And it's a public repository, so I'm going to do a Git clone. So copy the clone command, then jump off to my IDE, then get from VCS, paste in my URL, then clone. So that's the basic reason I'll be using. I need to have Git installed. So I have cloned the repository to my local. So here you can see the README. So you can actually go through it to see some basic instructions on how to run, build, and publish the image. So typically, a Spring Boot application will have the structure. You have your pom.xml file, where you have the metadata for your project, and you have the dependencies for your project, and you also have the plugins defined. So here I have some Maven wrapper files because of Maven is the build tool I'm using in this project. Then I go into the source directory. I have a main and a test. So this test will be added for you automatically by Spring Boot. Then here I have my ECS demo application. So decorated with the Spring Boot application. And also this is my main class. So if you're a Java programmer, you know that the main class is the entry point for your application. So basically, your Spring Boot application, because of it's going to be performing CRUD functionality, you want to organize your packages into like the MVC structure. So here I have the entity package. So this package is really going to contain your plain old Java objects, right, that will eventually become a record in your database table. Your repository package, right, is going to contain classes or interfaces that will handle the mechanism for interacting with your database. And also your service package is going to contain your business logic classes, and your controller will contain classes that will expose your endpoints. So I'm going to open my entity package. Here is my employee class, because of I will be saving employee records into the database. So this is a plain old Java object with 4 attributes. So I have decorated it with the @entity annotation. This annotation tells Spring Data JPA that this is going to be a record in the database, and this as ID annotation tells Spring Data JPA that this is going to be the primary key for this particular record. Now off to my repository. Yeah, so all you need to do in your repository is to extend the JPA repository, right? And a lot of things come to you out of the box. So with these, there are a couple of methods that you could just use without writing them. There's a way you can write your method names, and Spring Boot is going to provide the implementation for you. So also on my service here, okay, I have my employee service. So this is where the business logic. Here I have just two business logic, the logic to create the employee and the logic to get all employees. So typically, because of the employee registry knows how to interact with the database, you want to auto-wire the employee repository into your employee service, right? Then you delegate the methods to save and to find all to the employee repository. So to my controllers, here I have two methods here exposing two endpoints, right? So a REST controller declaration to tell Spring Boot that this is going to be a REST controller, a request mapping endpoint, annotation to show the paths that leads to this controller. And also I have to auto-wire the employee service here because of I'll be delegating the responsibility to create and get all to the employee service, which in turn delegates it to the employee repository. So this particular method will be called whenever a post request is sent to this path. And the post request is going to get a request body with an employee object. So all it does is to call the create employee method from the employee service. And also, when this path at all is called on a GET request, right, this particular method is called, and the employee service calls the GET employee method. So I could just run this application right now. Okay, I could run it from here or from here either. So close this up. And great. So my application has started on port 8080. So you can see Tomcat started. So because of in Spring Boot, right, we have a lot of dependencies that we could add. I added the Spring Data Web, and that Spring Data Web comes in with an embedded Tomcat. So we have Tomcat started at port 8080. So what it means is that if I go to my Postman, I already have it open, then I hit localhost port 8080/employee/all. This is going to call the get method, right, which I have defined in my controller. So if I should click a send, and of course, there is no employee in my database. So what I'm going to do now, I'm going to go to the post requests. So here, localhost 8080/employee, a post request, and the request body, right? Remember, the employee has an ID, first name, last name, and the department. So if I should send this, okay, it has been saved. Okay, I will just send another one, give it an ID of 4. This time around, the first name of Steve and the last name of last something, also in the IT department, and I send it, returns. So come back to the get all endpoints and assign your request. So you can see now we have the two employee records coming out from our database. So basically, that's it with the Spring Boot side, and we have been able to save the employee record to a database, and we've been able to list all the employee records from the database. So now the next thing we're going to be doing is to deploy the same application to AWS ECS. So go back to my IDE, and what I'm going to do next, I'm going to come to the Maven tab here, and I'm going to select a Maven Go Spring Boot run image. So now, what does this particular Maven Go do? I could have typed it on the terminal, but since I'm using the IDE, I could just run it directly from here. So what it does is that it builds an image, a Docker image for us. So this is one of the advantages you get when you use Spring Boot. So Spring Boot comes with a variety of tools that you can use for development. So with just a single click here now, I will just, as you can see, it tries to do the compilation to ensure that everything is fine. Then eventually, it begins to build an image. Okay, so the build is successful, but yeah, I missed something. Yeah, I did not change my image name. Okay, so basically, that is what that particular command is going to do. But because of I want to push the image to the Elastic Container Registry, I need to up to Amazon right now and create a registry. So I'm going to jump off to Amazon. So when you get to Amazon, you log in and you could just come to this bar and search for ECR. So ECR is the Elastic Container Registry. So if you click on that, it's going to bring you down to this page. So I don't have any repository yet. So I click Get Started. So create a repository, a public repository. I'll just call this Spring ECS because I'm doing Spring and ECS today. So I'm going to leave every other option like default. You could make it scan your image if you want to, add the encryption sets if you want to, but because it's just a demo purpose, I'm just going to create repository. Okay, filled with the repository error name. Okay, I've seen this before. Maybe I need to refresh this page. Let's do it again. Spring ECS. Leave everything as default. Okay, great. So now we have created a repository. So we need to be able to push our image down to this repository. So what I'm going to do is just to copy this URL from here and up to my IDE, right? Jump off to my pom.xml, and I go to my Spring Boot, my Maven plugin. So here I need to configure my Maven plugin to push the image to this particular repository and this name whenever I run the command. So if I, initially it pushed it to Docker IO library, blah, blah, blah. So right now it's going to push it down to this point. So I'm going to run that again. Maven, Spring Boot image, build image rather. So it's running, checking that everything is fine. Everything is fine. So it's building the image now. Okay. So it's going to do some pulling. Okay. Okay, maybe this may take a couple of seconds to do. So, but however, while this is going on, I think I would just also talk a little bit about Spring Boot because of at this point I'll be jumping over to AWS. So why did I have to use Spring Boot? So Spring Boot is actually a Java framework that allows you to build Java applications quite easily and quite fast. And another reason you want to use Spring Boot is because of Spring Boot is the most popular Java framework. So what it means is that if you run into issues, you could simply jump off to Google or jump off to Stack Overflow and type in probably challenges you're having, and you can be very sure that you will be able to get a solution. Okay, so now we can see that the image has been built successfully, right? So the next thing I'm going to do, I'm just going to copy this bit. Copy these bits and jump off to my terminal and just run a simple Docker push command. Paste it here. And great. So now it's been pushing. So I need to mention at this point that I already have AWS CLI installed and configured. So when I run this Docker push command, right, it automatically grabs my AWS login credential. So if you don't have your AWS CLI installed and configured, if you run the Docker push command with that particular image name, it's not going to work. So you want to make sure that you have the AWS CLI configured before you run this. So now, okay, it's going to take a while. So I'm going to jump off to my slides and talk a little bit about ECS. So there's some buzzwords I'm going to use going forward now because I'm talking about AWS ECS. Okay, I'm out of the Spring Boot section now. So I have talked about the Elastic Container Registry, ECR. So ECR is just basically a repository to store our container image. So what we are doing right now, the image that was built, I'm trying to push it to the container registry. So I've also mentioned a lot about ECS, is the Elastic Container Service. So basically, it's just an orchestration service that allows you to deploy and manage your containerized application. And also, we will be using Fargate. So ECS, right, has two launch type or launch options. So one of them is Fargate and the other one is EC2 instance. So we'll be using Fargate in this demo purpose. And what Fargate does is that it allows you to run your containers without having to manage server instances or clusters. So all you do is to manage containers and nothing more. So ECS clusters, so clusters are just going to be, in this case, are just going to be region-specific group of containers. So we're going to have a group of containers that will deploy to a specific region, and that makes up our cluster. So we also have ECS tags definition. So this allows you to specify which Docker image to use, which port to use or to expose, the amount of CPU, and also the memory to be allocated to your container. So in this case, everything we're doing, we are managing those containers, our images, the ports, and the CPU and the memories. So you do that in your ECS tags definition, which actually, if you write it by hand, is just a JSON file. So an ECS tags is an instance of an ECS tags definition. So when you write your ECS tags definition in a JSON file, then you create ECS tags from your ECS tags definition. And also, we'll be talking a little about ECS services. So the ECS service is actually, you use that to maintain a desired number of tags, right? So the idea behind the service is this: I could specify that I want, say, 5 tags running from this particular tags definition. So if I specify that, now Fargate will always ensure that at any given point in time, those 5 instances must always be running. If for any reason one of these instances tags goes down, the containers goes down, Fargate is going to spin them back up. So whenever, for production purpose, right, you always want to define your ECS services. So let's jump back to my terminal, and I can see that the image has been pushed to the repository. Jump off back to my repository and click on it. So we can see that the image has been pushed some 3 minutes ago. So what I'll just need from this bit is to copy the URL, because of I'm going to be needing it when defining my tags. So it has been copied. So the next step is to create an ECS cluster. So to do that, I'll just hop off to the search bar and look for ECS. So ECS comes, Elastic Container Service, click on it, and takes me to the landing page. So I have ECS and ECR. Okay, we've done ECR, EKS. So I just want to click on clusters. So Amazon has done kind of a good job here to make you get a cluster up and running. So I'm going to so easily click on Get Started. So the first thing I want to do is to define my container. Yeah, these are some predefined containers here, but I'm going to go for the custom. Click on Configure. I'm going to give my container name Spring ECS, and the image. Remember I told you in the tax definition, you define the image to use, you define the ports, and here memory limit, I'll just leave it basic, like because of this just a demo, just leave it soft limit, and image is good, then click update. Great, so I'm done with my container definition. So now, my tax definition here. So everything looks good. There is already a network mode selected for me. This is the permission that will be used to run my tax. Compatibility is Fargate, and of course the memory and the tax CPU. So what I could just do here is to just edit the name. I'll just call it Spring ECS. Then everything looks good, and click on save. So on the next button. So the next thing is to define my service. Okay, Spring ECS service has been defined for me. I could decide to increase the number of desired tags if I want to, but because of this is just for demonstration, I'll just make it 1, and everything looks good. So let's just jump off. And here, finally, my cluster. So you could see even from this particular diagram we have here, the core, we have the container, which we have defined, the tags, and now the service. So finally, we get to the cluster. I'll just call it Spring ECS. Spring ECS, and leave everything also as default, and click next. So I get to a page just to review. If I want to edit, I could do that. But I think everything looks good, and I will click on create. Okay, so now this is going to take some, let's say less than a minute though. So here we can see that the ECS resources are being created. So 3 resources will be created for me: the cluster, right? In the cluster, then a tax definition, so, and the service. So when the service is complete, I'm going to have a single tax that is being deployed into my cluster. So alongside, there are some other services that will be created for me, because those services are needed for this particular ECS container I'm running. So first of all, there's going to be a log group. So here, if I have several containers, all these containers, they are logs, they're going to be like a log stream, and each of the log streams will make up the log group. So it's basically a CloudWatch service. If I should click on it to take me to a CloudWatch page, let me just click on it so you see what I'm talking about. So it's basically a CloudWatch page, and the log stream is being provisioned. So it's not yet complete yet. So once it's complete, you're going to see it there. So here is also the CloudFormation stack. So all the resources that are needed to make this work are also configured here. And here, this is the VPC, that is the virtual private network here. So here on my VPC, I'm going to have 2 subnets and also a security group. And right now, I can see that all my tasks are complete and everything looks good. So I can go and view the service. Okay, so here is just, I can see that my cluster is active, just 1 tag definition. Desired count is 1 because of I just had 1 task in my service, and running count is 1, meaning I have 1 task running in my cluster. And of course, the launch type is Fargate. So this is my service details. I can click on this place to see the task. So right now I have just 1 task running in my cluster, Fargate launch type. So if I should click on this, so I have more details about it. And on my network tab, I can see I have a private IP and a public IP, and this is what I've been looking for. So I copy my public IP and I jump off to Postman. So my endpoints, here I have localhost 8080, so it's no longer on localhost, it's running on my public IP. And I send it. Okay, going over the network, and of course, we don't have anything in any records in the database right now. So what I'm going to do, I'm just going to jump off to the get command, get request rather, and send it again. Okay, Steve last this time around. Let me give him an ID of 1 and send it. Saved in the database. Then let's just give James Bond. Give him an ID of 2. Let's put him in the maybe accounts department and send it. Okay, so we have 2 records on the database. So if I should come back and do a get all, great. So we have 2 records in the database. So what we've been able to do right now is that particular Spring Boot application, I have been able to deploy it to ECS using the Fargate launch type. So let me jump back to my slides now and let's talk about the finishing notes. So yeah, so I'll be talking about the pros of ECS Fargate. So first of all, with Fargate, you don't need to manage infrastructure. So all you need to do is to manage your containers, right? You define which image to build your container from. You define the ports, you define the amount of CPU and the amount of memory, and also other specific container things. So with Fargate, all you just do is manage containers. It takes away from you all the tasks of having to manage your instances, managing whatever other things I have to run on your instances. And also you can see that it was so easy to launch. And if I need to scale it, I could just jump over here and edit it and just increase. Okay, jump over to my cluster and come somewhere here, service, and I try to increase the number of the tasks here to 2, and that's it. So now, yeah, another advantage of ECS Fargate is that the costs. Yeah, so you can see I put lower costs, maybe. So why is this so? The reason is because of comparing ECS Fargate and the EC2 launch type, right? There is a certain threshold that you're going to run your ECS Fargate, then you're going to have a cost-effective. It's the entire system will be cost-effective, right? I'll use the right language for that. But if you're going to run your ECS Fargate, right, for a longer period of time, then there is a possibility that it's going to cost you more. So going to the cons, right? So if you are a user that you need to have greater control over your containers, then of course you may not want to use ECS Fargate. You also may want to use ECS EC2 launch type. And of course, if you're going to be running your containers for a prolonged period of time, then there's a higher chance that you're going to incur higher costs than when you run EC2 instances. So basically, that's it. So I think we could take some questions now.
Of course. Thank you, Stephen, for an extremely detailed presentation. And everyone can learn right now and launch their startup with the promises for a new unicorn. And the public is very active with questions. There's so many, I don't know whether I should ask everything right now. But let's start from the bottom, I guess. And then the first question would be, what would be the alternative to ECS without using the cloud at all?
An alternative to ECS without using the cloud at all, meaning you want to run it on premise.
Most
so
likely,
you may
yes.
want to use Kubernetes on premise.
Yes. Yes, that I agree. Kubernetes, Docker Swarm, or other orchestrators that allow you to run containers. Yeah, that would work. And then related question is, and also cryptic a bit, so pay attention. I've once been told that AWS Fargate is for ECS and EKS, what AWS Lambda is for EC2. For example, serverless versus non-serverless. Would you agree with this analogy?
Okay, for Fargate, I have an understanding about that, but for Lambdas, I basically have not used Lambdas much, but I wouldn't, really, I can't give you a direct answer to that because of I cannot tell you so much about Lambdas right now.
Yeah, so let me help you a bit here to understand. So ECS and EKS are alternatives, and Fargate is built on top of ECS. So that's not entirely different things than you would say I'm firing up a machine on the cloud, and I'm spinning up a service in the cloud. So they are not so different as would be serverless versus non-serverless. Yes, moving on. So then on how AWS ECS differ from AWS Lambda is, do you want to answer that, or you would defer that to me?
So I actually defer the Lambda part to you.
Okay, agree. So differences are in whether you manage the servers that runs the service or not. So in terms of Fargate, that is built on ECS, that's more like Lambdas. But if you look at the ECS as a container service, then Lambdas would be way lighter thing to run and way quicker to spawn in new instances and scale. So that would be the main differences. Other questions? Yeah, controversial one. Can you use AWS CDK to deploy ECS? If so, why don't you?
Okay, so this demo was just to show you that of course how ECS can be used, right? But if you want, you can go ahead to use CDK to define your infrastructure.
Yeah, yeah, and this demonstration as a Spring Boot application was quite basic, and then the quite basic introduction into using AWS services, and so you don't have to learn Spring Boot and the things that Pius did with AWS CDK and TypeScript. So this way shows that you can learn the keywords easier and then upgrade yourself to AWS CDK, whether with TypeScript or with plain Java. And I guess that's it for now. If maybe there are questions from the audience on the topic? No? Then other questions we can answer at the end of the talk or in the networking part. So right now, I invite you for the longer break, so 50 minutes, and then we will come back with the last topic of Dennis and see how to manage the cost on AWS.
Nežinau, kieno šitas telefonas, bet tik norėjau pranešti, kad...
Autobusiukas, čia greičiau, lekiam.
O, tai davai su šito pafilmuosiu dar.
Tai jums visiems labai įdomu, ką mes su Klaipėdos ofisu sugalvojom. Šiandienę apie smėlį ir ne apie jūrą. Mes esam Zarasuos ir čia privaibinam kultūrą. Hei, 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 kolegučiai. Hei, 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 kolegučiai. Hei, hei, kolegučiai. Hei, 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 kolegučiai. Ar mums vieniems čia atrodo, kad su šitai žmonėm dažnai pritrūksta oro? Galbūt ir karantinas, padėkim apostrofą. Po barbecue party mes užkūrėm hofą. Hei, hei, kolegučiai. Hei, 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 kolegučiai. Hei, hei, kolegučiai. Hei, 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 kolegučiai. Dabar mes pradėjom nevengti, kartoti per dienas, kaip gera Klaipėdoj gyventi. Atvažiavo TeleSoftas, pakėlė normatyvą, mes išvydome Klaipėdą gyvą. Hei, hei, kolegučiai. Hei, 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 kolegučiai. Hei, hei, kolegučiai. Hei, 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 kolegučiai. No, yeah, but you feel like me, and we do wanna say one more time, sincerely. Kolegučiai. Hei, 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 kolegučiai.
Tiek ieškau, pagaliau radau. Jesus, kolegučiai, žinokit, jūs esat patys nuostabiausi. Everybody, you are the most awesome people in the world. We are TeleSoftas and we are power!
ground running. Baby, I'm running. Baby, I'm running. Running, running, running. Gonna hit the ground running. Running, running just as fast as I can. Gonna hit the ground running. Running, running just as fast as I can. Gonna hit the ground running. Oh, running, baby, baby, running, running now. Running just as fast as I'm running, just as fast as I can.
Hello, welcome back. Hello and welcome back to the last session of today. And here we have a great magician of ours, Dennis. And a couple words about him. So he started his career in university, got a diploma, then very wisely went for the support, learned all the issues and how to solve them, and was quickly promoted to the DevOps team, right? And from there, the sky is the limit for him. And he worked on the cost saving through his career. And right now, he will be talking to you about cloud cost managing and all the tricks, tips and tricks, how he can advise you to do similar things. So, Dennis, floor is yours.
So hey guys, my name is Dennis, and I'm going to be talking about cloud management. I know this is definitely an interesting topic after one, and I really want to thank Pius and Steven for their presentations, and we're going to definitely come back to them on a later slide. So why AWS isn't the big bad wolf? So why did I pick the name? So sometimes for me, it seems that when talking about the cloud, everything, everyone just gets immediately afraid because you look at cost savings. And when you open up AWS, you want to create your account. You see that little scary screen where it wants you to enter the credit card information. And you're thinking, wow, it's going to charge me everything. Well, you're definitely correct. Sometimes when you're thinking about AWS, it costs to think about AWS. So, yeah. So, a little bit about myself. I've been doing DevOps work for over 4 years now. I've started with the Google Cloud Platform, moved on to AWS. I haven't touched Azure at all, but I'm definitely sure you can use all of this stuff about cloud savings in multiple cloud environments because most of the services are built around the same. So it's microservices, Docker, everything. So yeah. So this is going to be the agenda. We're going to talk about AWS billing, region costs, EC2 and Fargate, stress environments, zombie resources, self-managing, summing up. And trust me, I'm not going to bore you with all the details. I'm going to keep it short, and it's not going to. It looks like magic at the moment, but trust me on that. It's going to get easier afterwards. So how does billing work in AWS? So you actually get billed for usage in AWS. Like I said, you think about AWS, you get billed. And in AWS, time is definitely money. So for example, EC2, you launch an EC2 instance, you get billed for the hours used. So when that instance is on a stop, you're not getting billed. Same with databases, RDS, you stop it, it's not getting used. You also get billed for data transfers. Take that ECS, ECR, your containers, they get transferred from service to service, you get billed. S3, you store data, data transfers cost. And you can also have licenses in AWS. AWS supports that as well. You can have, for example, OpenVPN licenses. So yeah, you definitely get billed for whatever you use. So that's why, like I said, whenever you join AWS, you enter a credit confirmation. You don't immediately get billed. You have to start using it. And AWS provides actually a lot of free services like VPC. You can play around. There are little EC2 hosts like T2 Micro, which you can play around. It's free for your university work as well. So keep that in mind. And the next thing I want to talk about, well, money in AWS. So keeping your bills in one place. So you know how you work in environments, you have Grafana dashboards, you have any other dashboard, and you have a little nice overview. Well, with billing, it's the same. You have to keep your bills in one place. So I like to keep the practice of having your bills in one place by linking your every single AWS account to a single billing account. Let me explain. You have 10, 5, 3 accounts. You set your one primary account as the billing one, and you link the other 2, 3, 4 to that main one account. So here you see we have this nice little overview here, where obviously for data reasons I had to remove the account numbers, but the first one is, as you can see, January, February. This is the production account. Second one, staging account, stress account, so everything. And you can see the linked account total is 52,000 for this month, for this year. So yeah, this is where it's really crucial to keep, because sometimes it can happen. If you miss out on one of the accounts, it can just sit there. And if nobody logs in, nobody goes into billing. Maybe accountants don't go in as constant, because as you can see, we have smaller accounts, like the one from the bottom, which costs roughly $500 a month. Yeah, definitely monthly costs, well, 500 is not much, but look, if you can see, in 4 months, it's almost $4,000. So if that account is just left there, sitting there, it's just costing you money. So maybe something is just running there and you're not using it. So yeah, AWS, these are more of the graphs that AWS provides. So these are on the house from AWS, free, so you might thought. So you can see it's predefined cost by service. So any service you use in AWS, you click on this graph, you see what the service costs to you, and it just graphs you per account because you linked all of those accounts in one place. And by linked account, running costs, and you can also create your own dashboards and stuff like that. And this really comes in helpful for a lot of people who might require, because you can export these as CSV files, XLSS. So accountants, everyone are going to be really grateful for you. So the next thing I want to talk about is AWS regions and costs and keeping stuff in the same region. I can't emphasize this enough. So AWS works this way. So you have regions in AWS, and I can't define you a certain amount, but every single region in the world has one. America's region, Europe region, Asian region, whatever regions you have. So, and some of them can be more expensive than the others. So for example, if you did some of the account in the European region, but I don't know, maybe you opened up your ECR, your Docker Container Registry in America, North Virginia region, that's going to be cross-region data transfer. So that's going to be transferring data from all over the world. And I can share you a little fun story. Everyone likes stories, right? All right, let's talk about a story. So I think it was maybe one of the days of the week. I think we had a deployment. And for some reason, cloud was set up in the way that our Docker registry was in the Northern Virginia region. And our ECS, maybe it was a dev environment, I can't tell right now. It was in Frankfurt. So we did the deployment in ECS. We forgot about it. Maybe it didn't work. Maybe we left home. Well, the next day we come back, and overnight it piled up to $3,000. Well, how? Single Docker image, if you don't love your Docker images, can weigh up to 500 megabytes. Well, imagine those 500 megabytes being downloaded every single minute overnight from all over the world. That's $3,000. So yeah, and if it was in the same region, the cost would have been, I don't know, just as an example, maybe $100. So that's just cross-region. And sometimes when you want to have, maybe you want to separate services. So you, maybe someone provided you a single AWS account, you really love any region, but you want to open two different stuff. You want to separate those services. And the better practice is going to be opening another AWS account, actually. It's not going to be open up and popping a different region. It's actually going to be opening another AWS account. And that way you can keep the stuff in the same region, and cross-account stuff is always cheaper than having stuff in multiple regions. So yeah. So the next stuff I want to talk about is going to be EC2 and Fargate. So it's a little more, it's a little bit more simpler because everyone uses EC2, maybe. Everyone uses Fargate because Steven talked about Fargate. So yeah. So like I said, on EC2, you get billed for usage. So you run your machine, you get billed for it. And Fargate takes the hard work of you, takes the hard work of developers, everyone, because it's an all-in-one system. You basically set up your machines and you forget about it. But if you really want to talk about cost, you have to look at EC2 as well, because if you can be flexible, you can set up EC2 in a way where it saves way more money than Fargate, because EC2 is flexible. You can have an on-demand instance. Obviously, it's in the name, it's on demand. You click on the instance, you have it, but you pay premium for it. You pay what AWS wants you to pay. But there's also different ways. One of the ways is actually the spot market, and spot market is you switch the roles. You basically tell AWS what you're going to pay for that EC2 instance. And obviously there's a lot of EC2 instances, a lot of machine types, little instances, bigger instances. So you basically tell AWS, hey, I'm going to pay for that. Well, if you're not happy about it, give me a smaller instance. So, and there's, so yeah, this is basically the SPI request. If you look here, this is constantly look. If you look at the created tag, maybe some of the instances got created 2 hours ago, but they were canceled because you lost the spot market because I told AWS, hey, I'm going to pay you a couple of cents for the hour used. And so they canceled it because it works in this way. Obviously, if you get outbid by someone else, AWS doesn't reserve you that instance. That's where on-demand falls for, because you demand it. But in Spot, you basically lose that instance, it gets shut down. So, and it's a nice flexible way if you can keep your cloud redundant, if you can take a node loss. So that's definitely some of the architectural things. But if you want to save, you can definitely save. And we use this tool called Spotinst, and it's a really nice tool. They were a startup once. They basically automate the Spot stuff for you, and it's really simple to use, trust me. You basically log in, you run a few commands, so your AWS account gets tied to Spotinst. You basically click a few buttons. You don't even have to write. You have templates, but you click a few buttons, and Spotinst actually creates a cluster for you. And if you can look here, this is for the past 90 days, so 3 months. So the first one is prod account. So it automatically projected the potential costs if you were using on-demand instances, and it projected you the savings. So total saved in 90 days is $3,000. And this is the dev account on the bottom here. And you save $2,000 in the past 90 days just by having a spot market. So, and it's really simple because you have a lot of machine types. So you basically, you know, when you go in, you click all the boxes. That's what you do. You click all the boxes. You tell AWS, hey, I'm going to pay the bare minimum for it. Give me the boxes. And Spotinst automates that for you. So if you have your cloud flexible, if you have the cloud redundant, you can accept a few losses because you have auto scaling. So machines get scaled up automatically. So it's basically the same. So if you can keep your services separated in a few different machine types, then it definitely works for you. So the next thing I want to talk about is dev and stress environments, and these are really lovely because I'm going to be talking more about the stress environments actually, because sometimes when you have a bigger project, a bigger company, stress environments can be parallel to your production, so it costs basically the same, if not more. Sometimes in a lot of cases it can be a lot more. So a nice thing to do with stress environments is really looking on how you can save on those. And one of the nicer things is actually having the environment on a cold standby. And cold standby is basically, you have, like I said, it comes back to EC2 and everything, you get billed for usage. So if you have your environment on cold standby, everything is shut down, you don't get billed. So if you have really powerful machines there, just sitting there, you can just, over the weekend, you can leave, turn everything off, and you can automate it. You have Jenkins, you have all of these beautiful tools in AWS, and you can automate everything so everything shuts down. Whatever it takes, maybe on a Monday morning when someone comes in, QA developers, they need it, that can be up and running in 10 minutes, and bigger clouds, bigger projects can be up and running in 45 minutes. But I'm talking about huge environments with databases, EC2 hosts, everything. So yeah, and actually we have a fun story, another fun story. Yeah, what a shocker. So what ended up happening is that you know, like I said, stress environments cost a lot, and the stress environment we had was really parallel to prod, but it was way beefier because sometimes you don't want to test on live clients, obviously. You want to test on your stress environment. So it was really beefy, and we had the cold standby set up. And someone forgot to shut down the cloud. So do you know what ended up after a weekend? So a new car. So over the weekend, someone left on Friday, didn't shut down the machines, $35,000. So imagine explaining that to the client. Oh, sorry, we just burned $35,000. Obviously, you put it on Jira tickets. We did testing over the weekend. Yeah, you did. But everyone knows $35,000 was just lost. So yeah, so I really want to talk about stress environments because I see this a lot. So I know that a lot of you are really cost efficient, but I know that there's a lot of projects, a lot of companies where they have dev environments, stress environments. They're just sitting there. So imagine this. So maybe it's used during work hours. So that's 9 to 5. Yeah, it's used from 9 to 5. What about nighttime? What about evening time? No, it's not being used. Yeah, maybe you have nightly builds, obviously nightly QA tests, but yeah, all of that time. So if you compile that over a month, that's half of the time these machines are not even using anything. They're just running there. So yeah, I can't really emphasize this enough about having cold standbys in place and everything, really talking about your infrastructure. And that's where a lot of stuff like infrastructure as a code comes in handy, because yeah, if you have databases, obviously you can back up the data. You can turn off the databases, but with the machines, you can just with the flick of a finger, you can destroy everything. And then once you're ready, infrastructure as a code is there for you to cover. Everything is back up and running on a Monday. So yeah, the next thing I want to talk about is zombie resources and developers. And that's where Pius and Steven really come in handy. So they did their little presentations here. Yeah, they launched. Well, imagine if they launched a lot more stuff. Well, did you see them deleting something? No, they launched everything. We didn't see them delete anything. Well, imagine what's going on in the cloud right now. Money's ticking. Yeah, money's ticking, and money can be used anything. So I want to talk about zombie resources, and that's what they are. They're basically resources that are not even being used at all. They're just running there like zombies. They're just sitting there, waiting, idling. Maybe they're not even going to be used anytime soon or at all. So I want to show you this slide right here. So cloud cost before. This was before I joined one project, so it was $25,000 every single month for Smaller companies, that can be a lot. For bigger companies, that's not a lot. It's on debate here. But some of the accounts weren't even linked, like I told you, like previous slides, where you link the accounts. Some of the accounts weren't linked. That was costing an additional $5,000. So let's take it $30,000 a month. And yeah, when you look at it monthly, 30,000 we can take the loss. But if you look at yearly costs, that's where the big costs come in. So it's $300,000 a month, or a year. And after saving, that was just only looking at zombie resources, implementing spot market. And whole cloud works the same. Everything functions still the same. Everything works the same. And after savings, and look, if you look at the dates here, so that was for the month of April on top, because you got billed on May 3rd, so for that previous month. And then 3 months later, by the end of summer, no, just for July, at the end of July, it was already down by $20,000. Because like I said, above a few accounts weren't linked, it was $30,000, and you saved $20,000 every single month in 2 months just by implementing a little simple cloud saving tips. And what ended up happening is that you go into these, you basically log into those accounts. You look at the services because you have a nice little graph there. Like I showed you before, it was automatically generated by AWS, cost by service. You look at the services. Maybe you're familiar with some of them. I wasn't familiar with some of them because guys were using AWS Kinesis, and that's basically like AWS's version of Kafka. So it's a messaging service. And that was costing $7,000 every single month. I just asked a few developers, hey, are you guys still using it? Because I was looking at logs and nobody was coming in or going at that Kinesis. And I was asking the guys around and they were like, Kinesis what? Kinesis who? What do you do it with? And I did some meetings, obviously, because you can't go in and turn off everything just like that because stuff can break. But, well, it still turns around. Nobody was using it. It was just there idling because powerful nodes were spun up and it was just there. Maybe someone did an experiment. Maybe someone did a cloud presentation, I don't know, some months earlier and left the Kinesis nodes there because they forgot. So yeah, that's what zombie resources are, and you can look a lot of different services. Maybe data transfers that you don't even need. So yeah, I can't emphasize on zombie resources. So yeah. Next thing I want to talk about is on-premise clusters versus the cloud. So why using the cloud can sometimes be more beneficial. So yeah, if you look at the pricing, it can be a little bit more expensive, but cloud really gives you the customization. It's really flexible, and you can be a one-man army on a project instead of having 5 people. So that's where that's where I actually marked man hours. So how many guys does it take to manage an on-premise cloud, and how many guys do you think does it takes to manage an AWS cloud? So if you have maybe on-premise service, you have to file a Jira ticket, you have to get it approved, and maybe, I don't know, when someone feels like it, maybe 3 days later, you're gonna have your changes. Gonna have increased machine types and all of that. Where in cloud, it's just having a Jira ticket and that's it. You go in and do the change. And ease of use, like I said, you can be a one-man army in the cloud because there are a lot of stuff. You can have infrastructure as a code. Various different stuff here. So yeah, I really want to talk about that. It's not always about the money. It is about the money for some of them, for managers and everyone, but yeah, it's not always about the money. So to sum up, I really want to tell you to keep your bills in the same place, because then you have a nice overview. Just like with your services, you have dashboards, so why not having bills? And there's always stuff that you can save on, always stuff that you can save on. Just when I was doing this presentation, I was going through the accounts. For some reason, I don't know why, I'll have to look into it, but the cloud costs increased by $1,000 for every single month. So instead of $8,000 that we were paying in January and February, we're now paying around $9,000. Where's that $1,000 increase? I'll have to look at it. So like I said, there's always stuff that you can save on. And zombies are everywhere. I can't emphasize this enough. I probably said emphasize like a million times right now. But it's okay, because I can't emphasize on a lot of the stuff, and it's really easy. So when you go into accounts, there are S3 buckets, there are RDS. Well, funny thing about RDS, that when you stop an RDS instance, it does get stopped for 7 days. After 7 days, it automatically turns on, and you don't even know about it. Maybe you turned it off, but it automatically gets started. So yeah, that's where it's going to be better to back up the data and destroy the RDS instance. So, and unutilized hardware. So this is more of a debate reason, but sometimes when we have meetings and on a lot of startups maybe, people are afraid that stuff is going to crash when more load comes in. So they just beef up the instances so they can just be sitting there costing a lot. And when you look at usage during the past 7 days, CPU utilization maybe was 7%, memory utilization was, I don't know, maybe 2%, but everyone is happy. Well, no. Actually, when you have instances that are using 90% of CPU, 80%, 90% of memory, they're being utilized. They're basically machines, they're working, they're doing everything. So, and if you're afraid of, I don't know, spikes in load, then obviously you have to look at autoscaling. And autoscaling is what that is. You have smaller machines, but on load, it scales everything up. And then with zero load, it scales everything back down to a bare minimum, so everything just works. So yeah, that was my presentation.
Thank you, Dennis. Thank you for sharing your real life stories and the ways we can save money just by looking after our infrastructure around our environment. And audience, thank you for actively asking questions. We have some for Dennis as well. Let's start from one about the transferring costs. So does transferring data between, in example, EU West 1 and EU Central 1 cost money? If it does, is it cheaper than US to EU?
Yes, it's definitely cheaper because you have the same European region and it doesn't have to travel all across the world.
Yeah, and the rules are that you pay based on the origin price. So if US is costs X amount, then transferring from US to EU, you pay that price. And if you transferring differently, so from EU to US, you will pay the EU price. And transfers inside the region are free. So as Dennis said, better transferring inside the region than between the regions, despite whether the US to EU or EU to EU. And then the next one is there DevOps scripts that are public and can be used to shut down dev environments?
It all depends on how you want to do it. We did it with Circle CI, we did it with Jenkins, basically writing our own stuff, basically calling AWS when you have Terraform, everything set up. It all depends on the flexibility because there's a lot of ways to go there, but if you're familiar with Cloudformation, you do it with Cloudformation. Maybe you're familiar with little bash code and simple AWS calls like you do AWS S3 destroy. Yeah, you can use that. So it all depends. It's all flexible. I don't know. Maybe there's an all-in-one tool. I know that there's a gray tool called AWS Nuke. So once an account comes redundant, you basically download the tool and you nuke the account. It goes in and it deletes everything, so you don't have to go and click everything by hand.
Yeah, going through all the regions, making sure that you haven't left anything there. It's a painful activity, right?
Yeah.
Okay, and then the last one question. Are there ways to prevent the unexpected cost by maybe shutting down services when amount of dollars is reached automatically?
Yeah, because in AWS, you basically set your budgets and you can set the budgets per service. So yeah, it's really simple. So you set the budget for an X amount. At first, AWS sends you a little warning, hey, you're reaching your amount. But afterwards, it basically just shuts down the service because it wants to save you money.
Okay, so that's even better than I remember on Firebase. They just send you warning and keep burning your wallet.
Yeah, like I said, when you think about it, AWS, it costs to think about AWS. Yeah, they're really happy about their money.
Okay, and I see we have questions from the audience, right?
Yeah, so when even I talked about stress environments, so cold standby is actually come in place here. So you can have an account with a different region set up, obviously. Yeah, it's a really nice thing to talk about. We talk about it on the higher end of savings when we talk about with bigger companies that have cloud costs in millions for every single year. And that actually comes up a lot. So the strategy is basically, I forgot the name, but it's red, blue. Basically having, basically having an entire different region on cold standby, having your Terraform scripts up there, and having stuff backed up like your databases. So what you can do, maybe you count and you do some testing, and your downtime maybe can be 10-15 minutes, but you can have a whole region up and running just by having a region on cold standby, your data backed up, and you just switch your NS service to that region, and that's it.
And I would add that it's not a goal to stay in one region, and it's more on the path that you have to be mindful about where your data is and why you are transferring it cross-region. In your described environment where you want to have 2 regions with your app running for the redundancy, you pay that transfer cost to have the redundancy. It's simple, and actually that transfer cost is reasonable, and you will not get rid of it. So yes, there is availability zones as well. Very good mentioning, because every region has 3 availability zones, and they are completely separate. And there's a very low probability that all of them will be gone.
Unless you have everything on an island and the island sinks.
Yeah, that's very likely. Other questions?
Yeah. Yeah. Yeah, yeah. I know that reserved instances can definitely save you a lot of money, but in practice, and I did have some practice with reserved instances. I actually had a few meetings. I remember sitting with AWS guys, and they were offering us, hey, you're going to save this amount and this amount, but it's a really complicated topic, and it really depends on the environment, because you have to know, because they want to lure you in. Yeah, they're going to give you the savings, but you have to know what you're going to be doing quarters from quarters, months and months. Maybe some company policies shift, and you have more Jira tickets, you have more microservices come in, you have a lot of stuff come in, and then what happens is that you basically break the contract, because those instances you reserve, you paid for them for an entire year, but you don't need them anymore because you need more beefier instances, you have more microservices running on. And it's a really difficult topic, and it's a really high-end topic. So if you're definitely sure you're going to be using, and then again, if you look at it, so you're gonna maybe buy more expensive instances that are more powerful, and what I talked about, they're gonna be unutilized. So you pick up more powerful instances, they're gonna be running at 10% of their capability throughout the year, because you wanted to make sure, because you don't know what's gonna happen, but then you have to take in those costs in consideration, because if you have reserved instances and you want to expand your cloud, you're going to have more microservices, you're going to have everything more. So it's a really difficult topic. I know because I made everything really simple, but these questions are really hard, because I remember those 2-3 hour long meetings that end up nowhere about cloud cost savings, and they end up nowhere. So
yeah, if you want a base in here, so reserved instances save you money, and what you don't use end up in the spot instances where Dennis buys his cheap ones.
Yeah.
And so it's practical to buy a baseline of your resources. So you reserve like minimum amount that your app is running for, and everything in addition you buy from spot instances. So that way you have a strategy that I will run on this minimum that costing me, like, what's the biggest discount, like 50% if you reserve for 5 years or something?
Yeah.
So even greater? Yeah, so you get that discount for basic runs, and for the increased load, you get spot instances. And if you don't get spot instances, you go for on-demand. Because if you have a high load, most likely you have a profitable business to run, and it doesn't matter whether you run on-demand or on spot instances. Just whether you get a car after the month or you have to spend that money on a car and don't get it. Right. Haven't read about them, cannot comment.
Yeah, savings plans are, if you go in, and AWS basically looks at your environment and it offers you a little plan on savings, but a lot of the times maybe when you know your cloud and you really want to know your cloud, I always tend to ignore them because I know, I trust myself on the cloud saving because we had a lot of meetings, we had everything. Yeah, AWS obviously offers you, because it offered a saving plan on a dev environment and stress environments a lot, but I know that they were constantly used. But for some reason, AWS thinks, no, your hardware isn't utilized. And that's where it actually wants you to save a lot, is on EC2 instances. It mostly offers you savings on there, but yeah. Yeah. Yeah.
Okay. Thank you. Any other questions? Cool. Then we can go and try to wrap this event. Thank you, Dennis, a lot for sharing. So at the end, one word about me. Hello, I'm Neris Imanavičius. I'm CTO of TeleSoftas. It's really a pleasure to meet you and to see you all here. And if you are watching this as an intro into the all the talks, or you want to save a time and get the most benefits of it, so some key points to take away, to know. So as Pius demonstrated, don't be afraid to try. There's nothing bad happened over all the rocks he crossed. And failing is not an issue. You can adapt and succeed after that. So that kind of builds a recipe for you to move forward. Just try, fail, adapt, succeed, and repeat then. And if we talk for real, then Aws SDK gives you ability to control infrastructure and version it and share it with colleagues in deterministic way. You actually see what was changed. You can discuss about the changes. It's not like you messed around with the configuration and God knows what you changed. Then on Java, that's easy. Spring Boot, even easier to build RESTful web services. You can learn AWS from friendly console, control console that Steven demonstrated. It's easy to get familiar that way and then bump up your skill with the tools that Pius showed. And at the end, cloud is built to save money for you with the one asterisk, of course, if you use it smart way. So that's what Dennis showed us. And that's what makes cloud efficient and effective for our usage. So thank you for joining and spending time with us. Recording of event will be available. You will receive it with a newsletter after the talk. Yeah, thank you for coming. Have fun and good luck learning and hacking.